Today's lesson is going to be about using properties of logarithms to expand and condense equation or expressions using logarithms so that you can use them to solve later on, which will be the next class. So first thing you want to do is we have properties of logarithms that we want to memorize. And again, just like the ones we talked about last class, if you understand what a logarithm is, it makes it much easier to understand why these are what they are. So the first property says log base a of u times v. Notice the multiplication symbol there. It's not there, but it's understood to be multiplication. So remember, this is an exponent, okay? So think about back to algebra 1. If you have an operation of multiplications, that means to add the two exponents together. So notice we have multiplication here among bases. So we have base a of u times v. So we have multiplication. We can write that as two exponents that are being added together, just like whenever you were in algebra 1. When you had bases that were being multiplied, you added the exponents. What we're doing right here is we're adding the two exponents together. So multiplication can change to two exponents being added together. And the other one is division. Well, if you think back to algebra 1, when you talk about your exponent rules, when you divide, you subtract exponents. So you have one exponent being subtracted from the other exponent. And then the other one is if you have an exponent raised to an exponent, you multiply them. So what happens is this right here is an exponent raised to another exponent. So what you can do is you can rewrite that as multiplying one exponent times the other exponent. And so that's your other exponent rule from algebra 1. So these are all just extensions of algebra 1, understanding these are exponent rules now in logarithmic form. So now what we're going to do is we're going to actually use them. So the first one says to expand. Expand means use all the properties you can to make it as big as you possibly can. Make it as many logarithms as possible. So what you do is you come in here and you have log base 2 of 3 times x squared times y. So notice we have a multiplication symbol right there. We have a multiplication symbol right there, and we have an exponent of 2. So we're going to use some logarithms. So what we do is we split this up. Multiplication can split up as addition. So each multiplication sign is going to become an addition sign. So this is going to become log base 2 of 3 plus log base 2 of x squared plus log base 2 of y. Each one of those multiplication symbols becomes a addition. This is one exponent, this is the other exponent, this is the other exponent. So it splits up into 3. Now the last thing that you can do is this exponent property right here says we can take this 2 and move it out front. So the answer that I would be looking for would be log base 2 of 3 plus 2 log base 2 of x plus log base 2 of y. And that's just expanding. It's just using the properties. That's all you're going to be asked to do is expand and condense. Expand means make it larger. Condense means make it smaller. Okay? So now, natural log, same process. Remember, it's just base e. So we have division. So this will become the natural log of 4x plus 1 minus the natural log of 8. Oh, that's a square root there. Okay? So that's using the property. Now, one of the things that we haven't talked about a whole lot, and this is something that you guys need to be aware of, is square roots can be written as exponents. And this is something you would have talked about in algebra 2. A square root is the same thing as an exponent of 1/2 minus the natural log of 8. And notice what happens is this 1/2 now is a property where you can bring it out front, and you would get 4x minus 1 minus the natural log of 8. And this would be the version that I would be looking for on an actual test. Okay. And then the last one, we have multiplication and we have division. So what happens is this becomes log base 2 of, and there are a couple ways you can do it. What I would do is just do in order, do the multiplication first, so it'd be the square root of x plus log base 2 of y to the 4th minus, and I'm running out of room here, so I'm going to write it down below, log base 2 of z to the 4th. So this should all be on one line, but I kind of ran out of room, so I'm going to go down here where I can write it a little bit cleaner. Okay, so this answer would end up being 1/2 log base 2 of x plus 4 log base 2 of y minus 4 log base 2 of z. Where did the 1/2 come from? Remember that x, the square root of x, is the same thing as x to the 1/2. So this right here is really x to the 1/2, and that 1/2 can come out front. This 4 comes out front, and this 4 here comes out front. And so those are just ways of expanding it. So this would be the answer that I would be after. 1/2 log base 2 of x plus 4 log base 2 of y minus 4 log base 2 of z. And that would be the expanded form. Use all the properties you can to expand it. Show me everything you know. Okay, condense. Condense means make it smaller. So we're going to use all the properties we possibly can to make this as small as we can. So the first thing we're going to do is we're going to bring this 1/3 up, because there's a the property doesn't have anything to do with number, a coefficient in front of the logs. It's just a single log. So we want to bring that through, that 1/3 up. So this will become to the 1/3 power plus log base 3 of x minus 3 to the 5th power. Again, we're going to take this and move it up top so we can put those together. We have addition, so addition changes to multiplication, and when you change to multiplication, it goes from multiple logarithms to a single logarithm. And what I'm going to do is this 1/3 power, I'm going to change it to a radical, so that's going to be the cube root of x times x minus 3 to the 5th power. And this right here is your entire answer. And one thing that you can do to make that a little cleaner, so you know that all of it goes with the logarithm, is put that whole thing in parentheses so that it's very clear that that whole thing is part of the logarithm. Okay, same thing on the next one, b. First thing I'm going to do is I'm going to take that 4 and move it up, so that's going to become natural log of x minus 4 to the 4th power, minus, take this 2 up, so that's going to become natural log of x squared. Now we have division. Division, or subtraction, means to divide, so this goes to natural log of x minus 4 to the 4th power over x minus, or x squared. Notice you go from 2 logarithms down to a single logarithm. You do not have 2 logs. The log is, the subtraction changes to division because you're going to a single logarithm, and that's condensed. There's only one left. Okay, so you got it down to a single logarithm, and you used your exponent rules to simplify. Okay, now we get here a little bit harder. Notice this 1/5 is going to impact both of these, okay, because it's on the outside of the bracket. So what you can do is you can actually go ahead and put that together. So that's going to be 1/5, not 1/2. And this would be log base 4 of x times x minus 2. And then what happens is this 1/5, and I don't necessarily need the parentheses here around the whole thing, okay? If you want to put the parentheses in here, you could do it around the part that follows the logarithm, like this. And then this 1/5 goes up as the whole exponent, so then you could write this as log base 4 of x times x minus 2 to the 1/5 power. And if you want to clean that up a little bit, the better answer would be log base 4 to the 5th root of x times x minus 2. And if you wanted to multiply the x times x minus 2 together, you could. I would be happy with that answer right there. And there's that one. And notice we condensed it down to a single logarithm. Okay, so right here, this 1/3 is going to affect this first bracket, and then I have minus this second part. So what happens is I would go ahead and put these together and make this log base 8 of y times y plus 4. And then I would still have the 1/3 out front here, and then if you wanted, you could put that in parentheses, minus log base 8 of y minus 1. Now this 1/3 is affecting this first log, so what I would do is I'd go ahead and bring that up, log base 8, and then you would have y times y plus 4 to the 1/3 power minus log base 8 of y minus 1. And all I'm doing is I'm using those properties from that first page. Bring that exponent up top to the entire logarithm so it affects that whole parenthesis. So then this becomes log base 8, and I'm going to clean this up a little bit. The cube root, because the 1/3 is a cube root, and then I'm going to do y squared plus 4y to get rid of some of those parentheses in there, minus log base 8 of y minus 1. Now, what do? We have subtraction. Now we can put these two together. Log base 8 of the cube root of y squared plus 4y divided by y minus 1. And this is the simplified or condensed version of that original logarithm.